and the energy's building, but the focus is increasing exponentially.
Yeah, as Tori said during his interview, the teams are very disciplined, very focused on what they're doing, the operational sequence of events that they're following. They are making sure everything happens, especially in this T-4 and counting period, because there's a lot of things they have to do. They have to finish topping the vehicle, make sure that all the tanks, first stage, second stage on Centaur, are at flight pressures and full of fuel, ready to go for this morning. They have to make sure the FTS system is armed and ready for personnel safety just in case, so that the range can do that. They have to check the electrical and avionics systems. They have to make sure that the flight computer has all the information it needs to place Mars 2020 into the orbit it has to. So a lot of things going on. Exciting time for the team right now, but again, staying focused and following that procedure they've got.
3 minutes.
As we look ahead to post-liftoff, want to kind of preview for you what's going to happen, because there's going to be a lot going on. You're not going to hear much from us. You'll actually be hearing from the ULA flight commentator, Jesse Gonzalez. He'll be kind of giving those calls past liftoff that will walk us through maximum dynamic pressure and into SRB separation, and then into fairing separation, booster separation, and then the first main engine ignition of the Centaur,
yes.
RL-10. And so then you'll kind of hear us jump back in and help provide some more context to what's going on. We encourage you to stay with us for the rest of the show, though. There's a ton more content we have to bring you, and we are far from over. Want to emphasize that the countdown to Mars is not done at 0 today. The countdown to Mars ends in February, when Mars 2020 safely delivers Perseverance and Ingenuity to the surface of the red planet. So we're going to let you listen in now and enjoy the last couple minutes of the process of launching a rocket.
One minute 59.
Vehicle internal.
1 minute 55.
Launch sequencer start.
1 minute 50.
Securing Centaur LH2.
Securing Centaur LO2.
So there we heard the fueling is
1
wrapping
minute
up
40.
Yep, fueling is wrapping
Launch
up.
enabled.
Team's gone. Launch enable's
137.
done. Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to auto
FTS
sequence at T-31 seconds. So that's a big thing that they're getting done here. At T-25 seconds, we will hear the team give their final goes that everything is ready and
1
the
minute
launch
20.
vehicle is ready to lift off and
OCU
perform
armed.
this mission.
SCS count
1
started.
minute 15.
Produce CCS for launch. Roger.
1 minute 10.
Vent valves locked.
One minute.
Rock, report range status.
Range green.
That's good to hear, Joshua, right
That means
there.
public safety there is accounted for, the FTS system. There you see on your screen a beautiful shot. The skies look great. There is little wind happening. You'd be able to see more of the venting. If there were wind, the trail of that venting. So we're ready to go.
And actually, that's an
40
important
seconds.
point. The reason we don't see that
Stable at
venting is
step
the
3.
vent valves have been locked up to put flight pressure into the tanks. And as we just heard, they're stable at step 3, which means the tanks are ready to go. And here at about 5 seconds, we will
28
hear
seconds.
the team
ECS reduced for launch.
give their
Roger.
final go.
25 seconds.
Status check.
Go Atlas.
Go Centaur. Go Mars 2020.
There we go. We are ready to go lift off this morning, Joshua.
Eight, 7, 6, 5,
5.
4. Engine ignition. 2, 1, 0.
Release.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the red planet.
And Atlas TU has gone to closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas 5 is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly. And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly. And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance. Vehicle body rates are responding nominally at this time. And coming up on 2.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour. And the Centaur reaction control system is now pressurizing to flight levels. And just past 3 minutes into flight, the RD-180 is now throttling to maintain a constant 2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload fairing jettison and Centaur forward load reactor deck jettison. And the RD-180 is throttling back up to attain a 4.6 G acceleration. Engine response continues to look good. And Centaur has begun the boost phase chill down sequence to thermally condition the RL-10 for operation. Standing by for BECO shortly.
BECO's the call for booster engine.
And we have BECO, booster engine cutoff, standing by for stage separation. And we have good indication of Atlas Centaur separation.
So there you're seeing live footage.
And we
from
have
the
MES
rocket.
1. RL-10 operating parameters look good. Chamber pressures are stable. This will be the first of 2 burns for today's mission. This first burn will be approximately 7 minutes in length.
So Mick, that's pretty exceptional footage there. That's live video. We will see that switch over shortly into an animation that kind of helps let us know what's happening with the rocket. But right there, a beautiful liftoff. Fun to feel that rumble in the building here as we proceed towards orbit and then towards Mars destination.
Yeah, absolutely. It was great watching an on-time liftoff of the Atlas V with that little over 2 million pounds of thrust. Cleared the tower in roughly 5 seconds. Josh, you and I worked the InSight mission, and if you recall, that mission on the West Coast took about 17 seconds to get past tower. So with those 4 solids today, this thing really got out of here and on its way. And it's, as we hear from Jesse, everything's looking nominal, and all vehicle parameters are within the design limits, and we're getting ready to come up on a main engine start for that first burn that Jesse was talking about.
Yeah, so recapping this countdown to Mars, the stations began to be filled up this morning just after midnight. Preparations, fuelings, powering up, all the way through that liftoff that happened. I think, Mick, it wasn't precisely on time. I think you said it was like 10 milliseconds early. So it's pretty much dead on.
Yeah, dead on. This team does a great job. As I said, they're very focused, very disciplined. As Tori also said, courageous. They have done a lot of work to get us to this point today through this pandemic, changed how they did some of their work, made adjustments as needed, a lot of cleaning, a lot of things, a lot of wearing their face masks, doing all kinds of things. And so this is an exciting time, not only for the JPL team in Mars 2020, but everybody that's worked this mission, and for the country and the agency. So this is exciting to see. We still have a long way to go, Joshua, before spacecraft separation.
Yeah, we had a really quiet countdown today, which is phenomenal, that we got off the ground on time. And we are proceeding now that we are in the middle of the first burn. It's tough to make out, but that engine is lit and it's firing. So we are in motion. There you go. There's that animation we talked about.
To telemetry there as we switch to a TDRS-compatible data format.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see that the engine is lit, and that is driven by the data that says that the engine is truly lit and we're in this burn.
Yeah, the launch vehicle continues to send telemetry to the launch team via the TDRS network, as you mentioned, and that allows them to continue to watch what's going on and make sure all their sequence of events meet their timeline. We continue on a nominal flight this morning. This first burn, as we heard earlier, will be about 6 minutes. This will get us into that park orbit around Earth, allow us to get on our way, and then get into that approximately 30-minute coast period that we're going to have.
8 minutes into flight, beginning to see the Centaur PU system balance out mass errors, seeing very stable body rates in the Centaur.
So we've mentioned 5 teams at play, and although if you were watching, hopefully you got a chance to see this in person, if not on camera, it's easy to kind of say, oh, it's over, like job done, but all 5 of these teams still very much engaged, still very much focused, because there's a lot of work ahead as we proceed through this first burn, and then a coast phase, like you mentioned, Mick, and then a second burn, and then spacecraft separation and the acquisition of signal from Mars 2020. So a lot more coming up here. Mick, I know for Launch Services Program, you guys manage the launch. So what does that mean? I mean, this is you guys' work in action right now.
By the way, that's the 5th team that we didn't get to mention. We talked about JPL, we talked about DOE, we talked about United States Space Force, and United Launch Alliance. LSP, we are like the brokers to select this launch vehicle and help with manage this mission. So we get our spacecraft customer, the JPL folks, they come to us. They have some certain requirements that they need for this mission. The Launch Services Program made up of engineers and flight analysis folks, and they look at everything, they help define those requirements, and then we go out and procure a vehicle from a commercial partner. In this case, it was the Atlas 541 for the Mars 2020 mission that was needed for performance, right? As you and I have talked over the last several days, Josh, one of the things that was important for us to look at was that performance, to be able to get Mars 2020 onto that transfer orbit into solar orbit to intercept Mars in 7 months. It's kind of analogous to a football game, right? With a quarterback trying to throw a pass downfield. You need a quarterback with a lot of performance who can get that ball down there where it needs to be, and so the receiver can intercept that. In our case, 7 months later.
There you go. Yeah, it's the longest football pass ever. The Earth is the quarterback. The Atlas is the quarterback's arm. Perseverance is the football, and Mars is the receiver.
That's exactly right.
And what we also talked about is that technically you could launch to Mars at any time if you had a rocket that was powerful enough. But this is the launch period every 26 months or so, as we've talked about, that makes the most sense because you require the least amount of energy to get to Mars because it takes a lot to get there. Obviously, like the Atlas 541 is is a workhorse.
Yeah, as Tori said, it's their Dominator. Right?
There you go.
I love that name for the Atlas V 541. But we heard Jim Bridenstine, our NASA administrator, tell us that if we didn't make this launch period, we would be down for roughly 26 months.
It's
right?
tough.
So the period started July 17th and goes to August 15th. Today, July 30th, was one of those launch opportunities that we had. We had a 2-hour window, and within that window, we had several opportunities.
25 actually.
Yeah.
25 opportunities.
And we launched at the beginning of the window on our first opportunity to get Mars 2020 going on its way. And that, that sounds like a lot, and it is. The flight analysis group, both at JPL, LSP, and ULA, did a lot of work to pick out those target sets and figure out where we needed to be. So they've done a great job, and we'll see how this mission continues.
So, Mick, tell us about the 2 burns required here, and we're actually coming up on the end of the first one. Ultimately, a lot of people probably, and myself included at some point, just like, why wouldn't you just keep firing the engines? Just fire all the way through and get to Mars in one shot.
So the first burn gets us into that park orbit we talked about. We've lifted off, we've left Earth, we've got into a park orbit around Earth right now, and while we're in that park orbit, we will perform some maneuvers to kind of roll Mars Perseverance and the Centaur and coast during that time, basically setting itself up looking at the sun and away from the sun to control the thermal environments that are on Mars 2020 during this coast period. That coast period will allow us to coast around into the position that we need so that we can have that second firing to get the velocity needed to head off into Mars.
Yes, and we will be back for that second burn in just under 30 minutes now. But for now, there's more to learn about this mission and all of the amazing science that's involved. Daryl, back to you.
All right. Thank you very much. Great launch and great job, guys. Back outside now to recap. An Atlas V rocket carrying Mars Perseverance rover launched on time from the Cape Canaveral Air Force Station at 7:50 a.m. Eastern Daylight Time.
Incredible. After the rocket took flight, it separated from the first stage and was then boosted into orbit by the Centaur's second stage. Perseverance is now preparing for a second burn that will put it on a trajectory toward Mars. That's just incredible to say. It gives me goosebumps.
It really is, and we're so excited about that as well. And while we wait for that second burn, hang in there with us because we got a lot of exciting coverage to go. We're going to welcome in one of our launch guests, Dr. Derek Muller. He is the creator and host of the popular science education channel on YouTube called Veritasium. He also holds a doctorate in physics education, so he's really smart. And that's why you saw us kind of having some fun, because Derek was here on set and we're just having a good time talking about this launch, which I got to start off with that, Derek. Your first time seeing a launch in person, what'd you think?
I mean, what can you say? I have nothing to compare it to, but it was awesome, something I will never forget, and I definitely want to be invited back. So if you guys can make that happen, I mean, just so amazing.
You do a great job explaining physics. What did it feel like? Kind of walk me through as you were watching and experiencing it.
Well, it's like all the physics goes out the window a little bit. It's a very visceral moment between you and this very powerful craft. I think it's just amazing, all the, the engineering that goes into making something that's that powerful and yet that controlled, and to witness that is phenomenal. And then to feel the rumble of all that sound as it hits you, I found it an incredibly emotional experience. It's almost unbelievable to see it taking off. It's very surreal, that's for sure.
Nice. What excites you the most about the Perseverance rover?
Well, the Perseverance rover is going to do a lot of great science. So I'm excited, for example, that it's going to cache samples that we're going to bring back. Super excited that we're actually going to have samples from Mars in our hands. And I think that may clinch whether we can see that life is actually there. But I'm also super excited about Ingenuity, about the helicopter, which I got to visit out at JPL before it was strapped to the underbelly of the rover. And to think about flying a rotorcraft in, another world, essentially, in a place that only has 1/100th the Earth's atmosphere. Exactly. It seems audacious, and I am impressed and amazed, and I can't wait to see if it works. I'm cautiously optimistic. I think the team is phenomenal.
And you did, in fact, a YouTube story on it, a piece on your channel, and did a fantastic job going to JPL.
I did, yeah, and I was just so lucky that it was like there, a meter or two away from me on the other side of a door in a clean room, and that was, one of the great moments of my life. Yeah.
That thing's going to Mars.
Exactly. Yeah, and it weighs like about as much as my laptop.
Yeah.
And you think about, it's substantial in its size, and it's going to go there and take off and fly all by itself, because of course we can't control it given the time delay and everything. That is, I just think, one of the pinnacles of human engineering.
Yes, absolutely. Now, this is going to do some big science as well. What are your thoughts on the search for ancient microbial life on another planet, Mars?
Well, I think chances are good that Mars once harbored life. It was so similar to Earth in the past. One can only expect, life probably sprung up there as well. But I'm really excited for us to get that confirmation, because I think it really transforms our ideas about life and how frequent it is. Right now, all we have is this sample size of one Earth with life. If we find another one, that's 100% more information and data, and I think it's likely that life will not be exactly like ours. And I think it'll be fascinating, everything we can learn about other potential forms of life just by finding life on another planet.
You seem to suggest that you think there is life.
I do. I mean, you have liquid water for, I don't know how many, half a billion or a billion years. On Earth, that was enough to create life. So, the guess is that's not a unique thing, right? I mean, the scientific hypothesis is you run that enough times, it's bound to lead to life again in other circumstances.
Dr. Derek Muller, we really appreciate you being here, YouTube creator with the channel Veritasium. We know you have a 2.5-week-old child that your wife is holding down.
There are very few things that I could leave for, but this launch, that is one of them.
Thank you so much for doing so. Get a selfie with our full-size rover back here. You see that?
Please.
I definitely will.
Very good. Thank you so much.
There has been a lot of anticipation by NASA teams leading up to this launch, but some won't be able to fully celebrate until the rover has safely landed on Mars 7 months from now. Raquel, you're there with the Mars mission team at JPL in California. How are they reacting to seeing Mars 2020 take flight?
Well, Moo, it's been quite an eventful morning with the earthquake, but you could feel the energy building in the room in the run-up to launch. And now I'm with Bobby Braun, the Director for Planetary Science at JPL. Bobby, now that we've started our journey to Mars, can you tell me how you are feeling?
Wow, it's a great day. We're all so excited, and to get started in this way and to be on our way after all this work that the team has gone through. It's really just fantastic.
That's great. Now that Perseverance is off the launch pad, what are its next steps?
Yeah, well, we're almost on the path to Mars, if you will. The launch vehicle has done great so far. Our partners at ULA are just fantastic, and we're very happy to be working with them and for them to give us this boost so far. But we still have to have another burn of our upper stage. We have to pass through the night side, or the shadow of the Earth, come out on the other side and find the sun and power up, and then establish contact with the spacecraft. And once we do, we'll truly be on our way to Mars. We'll have a spacecraft that's power safe, that we can communicate with, and our journey will really begin.
We look forward to that. Thanks, Bobby. Now, Daryl, as Bobby mentioned, there's an excitement here in the room as the team looks ahead to the second Centaur burn. But before we get to that, let's learn more about the science on board this rover.
All right, thanks, Raquel. And as you mentioned, there are numerous scientific studies and technology demonstrations on Perseverance. Some of these are directly preparing us to one day send humans to Mars. One in particular is called MOXIE. Jeff Sheehy from the Science and Technology Mission Directorate is joining us now to explain, and he is here with us. Sometimes here at the...
A little difficulty with this technology
that's all
here,
right.
Daryl.
Well, that's all right. It's a Britney Spears style mic,
I'll hold it like this.
I don't know if you're... That'll work fine. We can hear you. Yeah. Thanks for making the adjustment there. So, Jeff, this is an incredible piece of technology here, this MOXIE, right? So tell us, what is it and why is it important?
Well, MOXIE stands for Mars Oxygen In Situ Resource Utilization Experiment. That's kind of a mouthful, so we grab a few letters out of there and just call it MOXIE. And I think the name MOXIE has a certain kind of attitude that's appropriate for this ambitious mission to Mars. But what in situ resource utilization is utilizing the resources that we find at a destination to produce useful commodities. And so what MOXIE is going to do is suck in the Mars atmosphere, which is mostly carbon dioxide, and produce pure oxygen. Oxygen is a commodity that we can use in our exploration endeavors, and so MOXIE is the first in situ resource utilization experiment on another planet.
How about that?
So that's why it's so important. If we can produce things we need at the destination, we don't have to load them in a launch vehicle, launch them from the surface to Earth, push them all the way to the destination and land them on Mars or the moon.
Saving incredible weight, fuel, resources to use them, the ones that are there and in place.
That's right. It took a lot of moxie. What were some of the biggest challenges in developing this technology, designing it, developing, building it?
Well, the team that produced the hardware that we just saw being launched on its way to Mars, they certainly had moxie because they had to overcome a lot of challenges along the way. When you start to develop new technologies, you're working in a laboratory and you've got all the room you need usually, and you can build it big and heavy because you're not trying to make it look pretty, you're just trying to make it work, and you've got all the power you need, and you can control the thermal environment, and you can have teams of people come in and tinker with it and fix it when it breaks and all of that. So, but and you can probably see where I'm going with this, when you get to the point where it's time to fly that hardware to prove it out in the space environment or on the planetary surface, then the rubber really hits the road in terms of the engineering, and that's where the teams of engineers come into play, and they develop clever solutions to implement the process that's been developed in the lab and package it for space flight. So MOXIE faced a lot of challenges. You know, once you have to put it on the rover, the size becomes important. It has to fit in a certain volume on the rover. The amount of weight or the mass becomes really important. Every ounce you launch into space takes propellant to move it. So we want to make MOXIE as light as possible. Had to fit within a certain mass budget, or they would have kicked it off the rover.
Yeah, and we're glad you made it on the rover.
Yes.
And just real quick, and without getting too deep into the technical details, how does it convert carbon dioxide to oxygen?
So MOXIE uses a thermal and electrochemical process. There's a compressor that was built by a company called Air Squared. Some of that was funded under the NASA Small Business Innovative Research Program, actually. And they built the compressor. What it does is acquire the carbon dioxide from the Mars atmosphere and push it into the electrolysis system. A company called Ceramatech, a team led by a guy named Joe Hartvigsen. They're now called Oxyon Energy, I think. But they built the guts of MOXIE, which is the solid oxide electrolysis system that takes the carbon dioxide, CO2, actually pulls an atom of oxygen off the CO2, leaving CO.
Oh, wow.
And then those atoms migrate through the electrolysis system, and those oxygen ions are neutralized, and then they recombine. An O and an O becomes O2. And so we get pure oxygen out of the system.
That's fantastic. And so in order for you to get MOXIE on board the rover, actually you had to kind of clear through the very smart lady to my left. She's with Planetary Protection. So she actually had to clean off part of it, right?
Yeah.
You had to heat it and then clean the
That's
O2
right.
sensor.
Yeah, the SOx part was actually self-sterilizing. It was hot enough so it cleaned itself. But there's a part, the O2 sensors, that needed vapor hydrogen peroxide sterilization. So it was the first time we used hydrogen peroxide on flight hardware.
Oh, that's awesome.
Yeah.
So you can say thank you.
Thank you.
Thank you. No, thank you.
Appreciate it very
Thanks
much.
for letting us do that.
Well, you know, in speaking about the rover, Moo, what is it, you know, Curiosity told us that we have, or had at one time on Mars, moving water.
That's
so,
right.
So what is Perseverance going to do in terms of confirming whether life could have been there?
Yeah, exactly. So the past missions set up the stage as far as understanding what could sustain life, and now we're actually looking for signatures of that life.
And so some of the answers that you're looking for, which one are you personally looking most forward to?
Yeah, I'm personally looking forward to seeing signs of life where no one will argue that it has a biotic source. It's very easy to say, oh, this chemistry could have happened from natural reasons, but I want to see a smoking gun. It would be awesome to see that.
Now, that's not exactly easy, right?
No, not at all.
And so explain that to us.
Yeah, so in order to get that definitive signal, one of the main things you have to do is make sure you have a clean instrument that you're sampling with. And so that's why we spent a lot of time cleaning, baking out hardware to such a high degree, 150 degrees Celsius for some of these parts, to make sure it was clean enough.
And so those parts have to be specially made to be able to handle that heat.
That's right, yeah.
In order to get it past you.
Yeah, all of the material selection, everything was done specifically for that purpose.
Where else in the universe, Moo, do you think we should explore for life?
Yeah, I'm really excited about Europa. Europa has an ocean underneath a thick layer of ice. It has vents underneath that have a heat source, so there's a source of energy for possible life.
Europa, a moon.
Yes, a moon. Yeah, icy moons. That's the next place to go.
It's interesting that you picked that. I mean, it's a very, very cold, cold place.
Yeah.
You've got a rover in front of you that is
I
miniaturized.
do.
We have one that is behind us.
Yeah.
Right? And as part of this, you also had to make sure that that nuclear battery was installed.
Exactly.
Yeah, there it is.
Yeah, this bit back here.
Tell me about how that worked, when you did it, and how that process was.
Yeah, it was only a few days before this launch day. I mean, we just finished counting our samples just a couple of days ago.
How about that?
Yeah, so we had to actually alter the way we sample. We take wipes and swabs of every surface of the rover. But for this, we had to make sure our head was far back and we had as minimal radiation impact as possible. But we got it. It was super clean. INL did a great job. Everyone has done a fantastic job making sure this was as clean as possible.